Example 15-1. Draw a system H curve. From a bureau pumping system with the maximum flow rate is the 0.2 cubic meter per second. Assume it's a cast iron pipe with the 200 millimeter diameter, and suction fitting consists of the foot valve. Case point A. Discharge fitting consists of the check valve. Case 2 and gate valve. Case 0.08. Water temperature is 25 degrees. Okay. Pipe connection is the flank type. Okay. So given a cast iron, so we can identify what is the roughness from the page 10-6. E is equal to 0.0085 convert to centimeter. So we got the roughness is 0.026 centimeter, and we can estimate for the relative roughness divided by diameter. So we got the relative roughness is 0.0013 is for identify the friction factor. And what is given, we can write down here is the K is a foot valve is about 0.28 this point, and the K is about for elbow, and K is for the check valve. K is 2. Is for group valve. K is K, and this one is K axis is about 1. Okay, so the next we want to find equation for head loss, total dynamic head. So the next step we find the area, because we given the diameter of 200 millimeter, and find the length. Okay, total length is 86, and list of the head loss from the minor loss. Okay, from suction end, from angle, check valve, gate valve, axis, and the major loss. Okay, so that is equation for the major loss. Is a function put in the function of velocity and function of friction factor, because we want to vary the Q. Okay, and the next total head loss in the pipe system. So we can combine the minor loss with the major loss. So okay, and finally we got this equation for head loss, for friction loss. Okay. Next step, we combine the friction loss with the static head. 21. Okay, so we got total dynamic head equal based on this function. Okay, and next we derive equation of Reynolds number. Okay, Reynolds number is a function of, we convert velocity in the term of Q. So we can get the Reynolds number is a function of Q. Next step, we draw a table. We vary the Q. Okay, vary the Q. Start from 0.02, and we, based on the above equation, we got the Reynolds number, and open the Moody diagram. We got the friction factor. We substitute in the equation of head loss. Got the 0.3 plus the static head 21.3. So we can do the same to increase the Q every 2.2, 0.02 until we got 20.2. Okay, and Reynolds number, friction factor, head loss, and total dynamic head. And next we can plot the curve like this. So this is the friction loss, and this is the static head. So we can come up with the, this is total dynamic head for this pipe system. In this equation, if we want to find, in this problem, if we want to find what is the head of the pump, we can start with the Bernoulli equation. For example, if we write Bernoulli equation from 0.1 to 0.2. Okay, so we can write the Bernoulli equation. plus the head pump is equal to in this case we say that P1 equal to P2. P is atmospheric pressure, and V1 and V2 is huge, the reservoir, so the velocity drop of water is so small. So we can cancel P and cancel. So we can estimate that head pump is equal to difference of static head and plus the head loss come from the major loss plus the major loss plus minor loss. Okay.